So we're going to continue looking at graphing these functions, and we're going to look at how we can put these different pieces of information together to get a sense of what the graph looks like. So there's a couple things I want you guys to consider, and one is the points of discontinuity. So discontinuity can be vertical asymptote when we're dividing by 0. It can be holes in the graph when they divide by 0, but where those factors cancel. And we can have breaks in the graph where the limit from the left side is not equal to the limit from the right side. So for example, it comes like that, and we get breaks in the graph when we do that. So those are some things that we want to consider. These are not the only things we want to consider, but these are some of the things we want to consider. Okay, so we're going to add on to this as we go along. So this example here, we've been given some information about the f prime, f double prime. And you're asked to sketch the function, and they give you some other information here in a table. They also tell you that it is continuous, which is very important, and it is differentiable, which is also an important piece of information because it also tells you that it's smooth. So we're looking at some of the limits here. So limit as x goes to 0 from the positive side, it goes to negative infinity. So it looks like there is, especially when we put it together, the domain looks like there's a vertical asymptote at 0. It also tells you as x goes to positive infinity, the f of x comes down to 0. So it looks like there's a horizontal asymptote in here as well. So I'm just going to draw in the horizontal asymptote here and a vertical asymptote in here. Okay. So looking at the table information, it tells you some more information. It says f of 1 equals 0. Okay, well, that means that at 1, we get an x-intercept. Tells you that for x is less than 1, it's going to be below the x-axis or less than 0. And for x is greater than 1, it's going to be above the x-axis, so it's going to be greater above 0. So it looks like it's going to be a graph down here and a graph on this side. Okay, so they give you some information about the derivative. Okay, the derivative of this function at 2, we have a 0. So that could be a min or a max. Now, putting a slope chart in here, okay, at x equals 2, the f prime values, they tell you from the chart here that if it's less than 2, the f prime is above, or is bigger than 0, so it's pointing up. Okay, and they tell you also that f prime, when x is greater than 2, is less than 0, so it has negative slope. So it looks like that is a max coordinate. It doesn't actually tell you the coordinates, so I don't really know how high to draw that, but we're going to draw that somewhere up there. The last bit here is giving you information about the second derivative, which is the concavity. So it tells you that at x equals 3, we have something going on here. Okay, at x equals 3, we have a 0 concavity. And it tells you less than 3, we have negative concavity. Okay, so it's concave down, which is kind of what we're seeing here. And on the other side of that 0, it actually switches from negative to positive. So it looks like that's an inflection point. So we have positive concavity here. Okay, so somewhere in here, there's an inflection point. So putting that all together then, we want to graph this function. We know it's got a vertical asymptote, goes through 0, has a max, hits that point, the concavity changes, and then it follows the horizontal asymptote there. Okay, so that's what the graph looks like.